recording. Yes, there's a question. This question will involve a little bit of differentiation and integration, so don't be afraid of that. The question is a constant and low in a circular ring of the radius capital R. So let's name this as ring one. Okay? A second ring, basically ring two, whose radius is smaller. Well, small r is much, much, much smaller as compared to capital R. Is moving with a velocity in such a manner that such a manner that the plane of the ring 2 is parallel to plane of the ring 1 and they have a common central. Now the question is find the maximum EMF induced in a ring 2. So the question is something like this. Suppose if this is the axis of the two rings, so basically this is your ring 1. Two. So this is your ring 1 and control C, control V, and let's make it very small. So guys, can you see ring 1 and ring 2? Can you see the planes of both the ring are basically what? Perpendicular, parallel to each other, and they have the common axis. This small ring is moving with a velocity how much? V, right? Yes or no? Hello?
Yes, sir.
So basically this ring is moving. Now what was happening? The this ring was having a current I, due to which what was happening, the current, if this was the current over here, so let's do the magic. Why it is not getting? So suppose the current is like this. When the current is like this, let's say the magnetic field whatever is this, we don't want the, we just want what is the maximum EMF induced in the ring. Basically we want just the maximum value magnitude. Okay, I'll write over here. I want the maximum magnitude of EMF induced in ring 2. So first of all, if I say that the small ring, the radius of the big ring is capital R and the radius of the small ring is small r. Okay? If I say the distance between the two is basically how much x, if I say the distance between the two is x, then can I say velocity is basically the rate of change of dx by dt? Can I say this? Guys, can I say this? If velocity is basically this and if the center of distance is this, then can I say this? The velocity is basically the rate of change of position. Yes or no?
Yes, sir.
What is responsible for the change in flux? Can you see there is a relative motion going on? So whenever there is a relative motion, then what will happen? EMF will be induced in the smaller ring, right? Yes or no? So that EMF we need to calculate. We need to calculate the maximum value of that EMF. So suppose when ring 2 is at a distance x from ring 1, then the flux through it, can you say the magnitude of flux through it? The magnitude of flux will be B into A into cos theta. Let's take it as 1 because can you see over here? Magnetic field will be like this or this. Hello? In both the cases, the angle can be, the angle of the area vector will be either 0 or 180. So if I just talk about the magnitude, then it will be into B into A, right? So this will be equals to what is the magnetic field due to a ring at a distance x. If everyone remembers this formula, mu naught by 4 pi twice of pi I a square upon a square plus x square to the power 3 by 2. Yes? Yes or no, guys? Hello? So basically, we know the formula. So now B, this will be equals to mu naught by 4 pi twice of pi. The current in this is in capital I. What is the radius of this thing? Capital R square divided by R square plus X square to the power 3 by 2. Is this the magnetic field? Yes. What is the area of the small ring? The area of the small ring will be pi into small r square. This will be the flux. Yes. Yes or no?
Yes, sir.
So basically this will be flux. Now we everyone knows this thing. E is equals to d phi by dt magnitude wise. Yes. Yes or no?
Yes, sir.
The E will be equals to d phi by dt. The d phi by dt. Can anyone differentiate this from 2 pi I r square plus x square? Can you see this mu naught 4 pi 2 pi I r square? It will be constant, right? Even this small pi r square will be constant. What is the only variable thing over here? The only variable thing is basically the one which I'll write in red. I'll change the color over here. So this will be. So this is the only variable thing over here, right? Rest everything is constant. So basically when I differentiate this d by dt of this, है ना? So start differentiating. Can you see it is 1 upon this thing? Just give me 2 minutes. Hmm. Yes, guys, please differentiate here. Ajit, yes, guys, anyone knows how to differentiate this? Can you see this will be 1 upon x to the power 3 by 2, so I can write it as 1 upon something to the power minus 3 by 2. So can you see minus 3 by 2 will come in the front and it will become minus 5 by 2, right? So this will be uh, minus 3 by 2 into r square plus x square to the power minus 5 by 2 multiplied by. Now we'll differentiate this something. So when this something will be differentiate, r square is a constant thing. X square will become 2x into dx by dt. And what is dx by dt? Dx by dt was nothing but dt. See, I applied chain rule over here. So basically, when I do differentiation of this function with respect to time, I get this. Everyone knows differentiation, right? Yes or no, guys? This 2 and this 2 will get cancelled out with each other, and the final answer will be mu naught by 2 into I by r square into mod r square into minus 3 by 2 r square plus x square to the power minus 5 by 2 into x. Is this clear, guys? This is the EMF. Okay, just the magnitude I wanted. So basically, this will be the EMF, right? Now, what was the question? The question was to find the maximum EMF produced. So we apply the concept of maxima
Maximum minimum.
and minima. So basically, you need to differentiate this again. When you differentiate this again, so basically, what to do now? You find d by dt, then equate dE by dt equals to 0. Yes or no? Yes or no? So I'll leave the differentiation part to you people. Equate dE by dt. And when you solve this thing, then for x equals to plus minus r by 2, E will be maximum. uh, And basically you'll put this x equals to r by 2 in the E formula. In the formula which is, so I'm leaving this process to you people. Okay. So when you do it, the final answer should be magnitude of maximum EMF should be mu naught by 4 pi into twice of pi into I into there should be r square because I asked for my first cancel into pi r square into 3 p by 2 divided by 5 by 4 to the power 5 by 2 and this will be r square. Something like this, it should be a random answer like this. है ना? तो एक बार ट्राई करना guys. It's a मतलब generally it's a question based on integration and all. Okay. Next question. Guys, there are two circular rings. Okay? This is also a circular ring, and this is also a circular ring. Can you see two circular rings of radius A and B? Radius A and B. Can you see this thing? Initially, they were placed like this. So, guys, everyone is able to see two different rings of A and B, right? Yes or no?
Yes, sir.
This is a region in which the magnetic field is varying with time. Can you see? Can you see over here? B magnetic field is given as a function of time. So with time, the magnetic field is increasing. The loop is in a constant shape like this. But basically, what is happening? I am increasing this time. Okay. If the resistance per unit length wire is lambda, find the induced current. Again, the straight part doesn't matter. Which is the straight part which I am talking? Guys, can you see this straight part here? This
Yes.
part. This part is resistanceless. Okay. This straight part is not having any resistance. You will assume this as like this gap is very close to each other, but these wires are not touching each other. This is almost a ring. Okay. This is also almost a ring. Now the question is find the current induced in both the cases. How will you do it? How will you do it, guys? Can you see for time varying magnetic field EMF E was equals to P pi by dt, right? Yes or no? What E equals to this? Yes or no, guys? And we know pi is basically what? Pi is basically what? N into B into A cos theta, right? So this will be A by EMF, which will be equals to N into B into A, sorry, N into A into, can you see? Whenever there is time varying magnetic field, only magnetic field is varying with time. The rest every other thing is constant, so it came out of the differentiation and it basically gave this, right? So try to use this concept and here can you see over here B is basically B naught by T, hence dB by dt will be equals to how much? Since B is equals to B naught into T, therefore dB by dt will be nothing but B naught. Is this clear? Array, is this clear? है ना?
Yes, sir.
Yes, sir.
चलो अब शुरू हो जाओ. Now this was the concept, and the question is in front of you. Start. Can you just give me the direction? Will you be able to give me the direction of induced current in both the cases? Guys, shall I do it? You are doing it. First case, guys, magnetic field is acting inside and magnetic field is given as B naught into T. Can you see when time will increase, automatically this will increase, right? Yes or no? So when time increases, B also increases because can you see over here the relation? So basically this magnetic field is increasing. That implies, guys, do you remember B external is increasing? If B external is increasing, what will be induced? Hello? Guys, do you remember Lenz's law application in the last class? The magnetic field is increasing. If the magnetic field is increasing, then what will be induced? Be induced
Should
will try to
reduce it.
decrease it, right?
Yeah,
So for decreasing it, the magnetic field should be acting like this.
opposite action.
The induced should be acting like this. So basically, can you see over here? For this should be to be the direction of the induced, the current should be going. In. So is the direction clear, guys? Of I induced. Is the direction clear? So now let's find it. Can you see here in this case, guys? Can you see the current is basically anti-clockwise, right? Hello, guys. Direction समझ में आया? We got the direction. Can anyone tell me what will happen to the? Can you see the direction of current is same in both the cases, right? In both the loop, the direction of current is same. Yes or no? So when I'm writing the total area will be pi a square plus pi b square. So this will be the total area plus. Yes or no? Since the direction of area vector is same, current was in the same direction. Hence, this was the case. Now phi b will be basically equals to what? The n, the number of turns is 1. So b is basically b naught into t. है ना? And what is the total area? Total area is pi a square plus pi b square multiplied by t. This is your phi b. So basically, if EMF I want, EMF will be equals to differentiation. which will be equal to time will become, it will become pi a square plus b square. And that's the answer for the that's the EMF, right? So what will be the current? The current will be basically this EMF divided by the resistance, right? Yes or no, guys? And they have given the resistance per unit length is how much? They have given the resistance per unit length is lambda. So the total resistance will be basically pi a square plus b square b naught. This is the EMF. Resistance will be 2 pi a plus 2 pi b. Was this the total length? Yes or no? Multiplied by lambda. So this is your final answer. Pi a square plus b square into b naught divided by twice of pi a plus b. So lambda pi se pi gets cancelled and that's the answer in the first case. Second case, guys.
Sir, why did we take 2 pi A plus 2 pi B?
Because the length of this wire, can you see the length of this wire is how much? 2 pi. The length of this is 2 pi b, and I told you this straight part is resistance less. I wanted to find out
Yes, sir.
resistance, right?
Mm, no, but the formula is E by R, right? So how do we connect?
We wanted to find out the resistance. They have given resistance per unit length. So I multiplied the length with the resistance per unit length automatically to get resistance.
Oh, okay. Okay, sir.
So the next, same thing. Same part, how the next part, how will you do it? Next part. In this case, what will happen? Suppose in this case, the magnetic field is increasing over here. Then can you see the current which will get induced? The current will it be in the same direction? Can you see if there is the bigger ring? The bigger ring, if I say the current induced, then what was the direction on which the current got induced the previous thing? Anti-clockwise. Then in the smaller ring, it will be clockwise. Ask me why. Can you see?
Why, sir?
Can you see the current when it goes like this? It will go like this, and then it has to go like this. Then only the loop will be completed, right? So can you see in this case the current through both the loops is in the opposite direction, opposite sense of magnetic field, right? Yes or no? This was the only difference between the first case and the second case. In this case, the current which flows, or basically which it gets induced in the opposite direction. Why opposite direction? Because can you have you ever seen if this is also clockwise, then how will the current flow? This, right? Are you getting my point? Will the current be able to flow in this like that? In this case, the current gets induced in the opposite direction in the two loops. That implies that area vectors point in the opposite direction. If the area vectors are pointing in the opposite direction, that implies when I will calculate the total area, the total effective area is basically pi a square, the bigger area, minus pi b square. This is the only difference, guys. The total area is basically this much. And now when you do this, it equals 3 pi by, you will write pi a square minus b square into 2. Now are you getting my point, guys? Yes or no? If you are not still not comfortable in this, first calculate the flux. phi will be equal to phi a square minus square into b, which is equal to phi a square minus b square into b naught. Guys, go through the whatever numericals we are going to, because those will be your foundation for electromagnetic induction. See the process what we do. The process is basically find out phi, differentiate that phi with respect to time, and automatically get E. And once you get E, you can get R I very easily. I is nothing but I by R. So I can write this thing as phi of A square minus B square into B naught and divided by the same resistance per unit length. Can you see the length of the wire is not changed, right? We just flipped one part. So it will be 2 pi a square, 2 pi a plus b into lambda. So pi and pi will get cancelled out. This I can write it as a plus b, a minus b, a plus b, a plus b will get cancelled out. Final answer is not. That's the answer. Okay. It is clear. Please, whenever you're done writing, just tell me. We'll start with the cause of electromagnetic induction. There are two causes. You're done? Guys, are you done?
Yes, sir.
Now, write down the heading. Cause of electromagnetic induction. Cause of electromagnetic induction. Basically, there are two ways in which you can induce an EMF, right? So, the first way is basically motional EMF. Can you see this is motional EMF? What is motional EMF? Can you see the term motion inside it? So motional EMF is basically, because of relative motion between the magnetic field and the conductor, right? So something related with motion will come inside over here. So we'll write that one. So whenever a conductor is moved in a uniform non-varying magnetic field, then we may get a potential difference across the ends of a conductor. Why is this potential difference across the conductor? We'll look at it. Don't worry. We'll see exactly what is there, and what will be the formulas and all. There is a derivation of that. So what will happen? Potential difference across the ends of a conductor. Why is this? This is because is a shift in the relative position of free charges inside the conductor. Okay, this EMF has a formula. Yes, this EMF has a formula. It is equals to V cross B dot 1. We'll see what exactly the terms mean. Okay, this is the first case, which is basically called as the motional EMF. So always remember, whenever a conductor moves in such a way that it cuts magnetic field lines, then only there will be an EMF induced in the conductor. So always remember, the lines have to be cut. If the lines will not be cut, then what will happen? There will be no EMF induced in the conductor.
Sir, can you scroll?
Sure.
Sir, done.
See guys, it's like suppose these are magnetic field lines. Can you see some magnetic field lines coming from the bottom and going to the top? Okay. Can you see my video? Hello.
Yes, sir.
Yes, sir.
Yes,
Now
sir.
see some magnetic field lines going up. And now suppose you have a rod. This is the rod. And this rod is going like this. Can you see when the rod will go like this? Can you see these magnetic field lines will get cut by this rod? Yes or no? Can you imagine the whole thing in front of you? Suppose the magnetic
Yes, sir.
field line is going like this and your conductor is like this. Okay? And now this conductor is moving like this. So can you see the magnetic field lines getting cut? Yes or no?
Yes, sir.
Yes, sir.
Whenever this happens, then only there will be an EMF induced. Okay? So if the magnetic field lines are like this, and if the conductor goes like this, you see the conductor is parallel to the magnetic field line, and now the conductor is moving like this. So can you see it is just brushing along the lines? It's not cutting the lines, it's just brushing along the lines. Yes or no? Here also it is just brushing along the lines. To cut the lines, it has to move like this, right? Yes or no?
Yes, sir.
So only in these cases where the lines will be cut, the magnetic field will be. Otherwise, okay. The second part is basically the second cause is, don't worry, we'll be discussing them in detail. Not the second cause because it's out of the part of your normal JEE mains as well. Advanced ke liye, yes, it is a part, but generally I have not seen questions, so we will not waste time on this. So due to a non-conservative electric, the first is basically what? Motional EMF due to motion. and second is basically due to a non-conservative electric field. Always remember it, guys. Suppose if this is a loop, okay, guys, can you see a loop? Suppose if this loop is at rest and this loop is placed in a time varying magnetic field. What do you mean by time varying magnetic field? The magnetic field will vary with time, right? Yes or no? So this is a loop which is placed in
Yes,
a
sir.
time varying magnetic field. What will happen when the magnetic field in the space changes with respect to time? Then this varying magnetic field induces an electric field inside the loop. This induces an electric field inside the loop. The induction of sorry, electric field inside the loop. Then you'll write this electric field. So developed is a non-conservative field. What do you mean by non-conservative field? It's a non-conservative field means what? The work done will depend upon path, right? Generally, electric fields are conservative in nature. That you the work done doesn't depend upon path, right? But this electric field which gets induced will be a non-conservative field. That applies the work done in moving a charge throughout the loop will not be zero. It will be something. Okay. So basically, to move a charge through the loop, certain work or say an skill will be developed throughout the loop to do the necessary work. Is this clear, guys? So basically, you need to do a work. So basically, suppose always remember in this case what is the direction of that electric field which I was talking. The electric field will be acting throughout the loop. For example, if I have this point, then the electric field will be acting at in a direction tangential. Electric field will be acting in a direction tangential, right? Are you getting my point? The electric field will be acting in a point tangential. So suppose if there are these points, so that electric field is always acting along the loop. Is this clear? This electric field acts along the loop. I can write inside the loop की जगह पे we can write along the electric field inside the loop along its length. So basically, along the length of the loop, this electric field will be existing. So that's why the direction was tangential at every point. Okay. So basically, if I want to move the particle from A to B, I need to do some work, right? Yes or no? If I want to move it from A to B slowly, then I need to do certain work. Yes or no? That work is basically in terms of what this work done will induce an EMF. Is this clear? So basically, these are your two causes of electromagnetic induction. So whenever there is a time-varying magnetic field, whenever there is no relative motion involved, then due to this non-conservative electric field, the EMF will be generated. And whenever there will be a relative motion, then due to motional EMF. Okay? Are the two causes clear to you? Let's discuss them one by one. Hello? Hello? Guys, hello?
Yes,
Yes,
sir.
sir.
Just give me 2 minutes, yeah? Got it, getting a call. Hello? Then it's guys, that number is not picking up, so it's okay. Now, EMF induced in the form magnetic. Basically, we need to find out what do we need to find out, guys? Motional EMF. We are deriving the term for motional EMF, okay? And this is the part of your school derivation, so yes, we'll do the whole thing. So let us consider a straight uniform wire. Can you see a straight uniform wire? Let's name it as PQ. Of length how much? L, moving with a velocity v in a magnetic field which is this clear, guys? Let us consider a straight uniform wire. Let us consider a straight uniform wire of length L moving with a velocity v in a magnetic field. In a magnetic field, like this shown. Is this clear, guys? Is the statement opening statement clear? There is this wire which is basically we are moving this wire with velocity v in the magnetic field v. So can you see this when this magnetic field when this rod will be moving, it will be cutting lines? Yes or no? Will it be cutting lines? Yes or no?
Yes,
Yes,
sir.
sir.
So see, guys, there will be free electrons inside this particular thing, right? There will be electrons inside this rod, right? So when the rod is moving, are the electrons also moving?
Yes, sir.
Alright. So can you see over here the free electrons are also moving along the rod with the same velocity v, right? So can you see whenever a charge is there which is moving in a uniform magnetic field, then what happens? It experiences a force. So then the force experienced by a free electron, and which force am I talking about? We're talking about the Lorentz magnetic force will be. So can you see over here the Lorentz magnetic force will be equals to the electron into V into B. Do you remember QVB sine theta? So can you see the angle between V and B is how much? V and
90.
B is how much? 90 degree. So hence, and the charge on that electron will be how much? Suppose this is the electron. Okay. So the charge on this electron will be how much? E. We wrote E. Yes or no? Array yes sir.
Yes,
Yes,
sir.
sir.
Now after this, guys, please can anyone tell me what will be the direction of the force? What will be the direction of force? V cross B. Can you see V cross B is pointing upwards? Do you remember? Guys, do you remember? You forgot.
So
V
we
cross.
remember.
So
Remember,
can you
sir?
see V cross B is pointing upward, but since it's an electron, hence it will the force acting on it will be in the opposite direction of V cross B, right? So this will be the magnetic force. Yes. Yes or no?
Yes, sir.
So now this force is acting in what direction? The force is acting from the direction will be from P to right. Now due to this force, what will happen? Due to the magnetic force, what will happen? Can the electrons are the electrons free to move in this? Right? So due to the magnetic force, the electrons will tend to move towards Q, right? Yes or no, guys? Hello.
Yes, sir.
Yes,
Due
sir.
to this force, the electrons will tend to move towards Q, right? If the electron will tend to move towards Q, that implies all the electrons will try to gather near the end Q, thus making Q slightly negative. Yes or no? Since there will
Yes.
be a shift of charge, so then Q will be slightly negative and P will become slightly positive, right? But due to the force, there is a shift of charges, and due to this shift of charges, what is happening? P is becoming slightly positive, whereas Q is becoming slightly negative. So this was the magnetic force, and due to which the Q became slightly negative and P became slightly positive. So can you see, guys, due to this positive and due to this shifting of charges, a positive terminal and a negative terminal, or basically you can say certain polarity is created across the ends of the PQ, right? Yes or no? Yes or no, guys?
Yes, sir.
Now, due to this shift of charge, there will be an electric field acting through the length of the rod. And what will be the direction of that electric field? Will it be from P to Q or will it be from Q to Q? Will it be from P to Q? Will this be the direction of the
Yes.
Yeah.
electric field?
Yes, sir.
And can I say this is the induced electric field in this case? Right?
Yeah. Yes, sir.
So electric field is induced now. Now due to this electric field, due to this induced electric field, what is the direction of force? The force acting on the electron will be, force acting on electrons will be Fe, which will be equals to E into Ei, and the direction of this force will be, always remember, it will be from Q to P. Why? Because we know electron is a negative charge, and always on a negative charge the force acts in the direction opposite to the electric field, right? So the force will act from Q to P. So basically this will be the direction of the electric force. Yes or no? Yes or no?
Yes, sir.
So can you see this particular
Yes, sir.
thing? There will be a shifting happening till that time. The shifting of charges will be happening till that time, till this force and this force doesn't become equal. The shifting of charges from one end to another end will happen. Guys, are you writing along with me? And please remember, this is very
Yes,
Yes,
sir.
important
sir.
as your school derivation. Acha, is this taught in your school as of now, guys?
Sir, we've not been taught this yet.
You have not been taught this. Electromagnetic induction, you have not done electromagnetic induction as far as the school syllabus is concerned, right?
So we
We
did,
did a little
but
bit and then we had vacation, so.
Acha. So, chalo, no problem. Still.
Hmm.
So Fe should be equals to Fd. That implies E into Ei should be equals to E into V into E. So can you see from here, E and E will get cancelled out, and Ei will be equals to V cross, oh sorry, vector form will write later, Ei will be equals to V into V. So can you see over here, the induced electric field will be equals to V into V. Sir, this formula is somewhat similar. You remember velocity selector? We did velocity
yes,
Yes,
selector, right?
sir.
So
E
can you
by
see V is
V.
equals to E by V? Same thing. In vector form, please remember we can write in vector form, this will be equals to I will be equals to V cross, and that too in the negative direction. The minus. You can, if you are, if you want to check, can you see on the diagram, the electric field was, induced electric field was acting towards this direction. This was the direction of EI. The velocity was towards this, and the magnetic field was towards this. The magnetic field was acting into the plane. So can you see what is the direction of V cross V? Guys, can you tell me what is the direction of V cross V? V cross V will be acting upwards. Yes or no? Can you see V cross V will be acting upwards? Can you do V cross V? Your thumb is pointing upwards, right? V cross V. And can you see EI should be in the opposite direction of V cross V? So this is very important relationship. Very, very important. So you can write it down. EI is this. Okay. Now the potential difference developed, or basically can I say induced across PQ due to the induced electric field is, let's say it is Vp minus Vq. Can you see over here, guys? I'll draw the diagram again. This end was P, this end was Q, and we know this particular thing, slight P is slightly positive and Q is slightly negative. So can you see this is at higher potential? Yes or no? And this will be at low potential. So higher potential and lower potential, what will happen? Vp minus Vq. The EMF is basically equals to, the potential difference is equals to minus of the electric field dot dl. If you remember this formula, this is basic electrostatics. The relationship between potential difference and electric field is given by this. Yes. And just now we discussed this, EI is basically equals to minus of E cross B. Minus and minus will get cancelled. You can write one more formula for the same. It will be V minus VQ will be equals to no minus, no nothing, because this minus and this minus will get cancelled. So V cross B dot. Okay. Please write this down. Please write this down. Okay. So always note. Achha, please write till here, then we'll do the note. Whenever you are done, guys, just tell me. Done. Hello guys, are you done?
Yes, sir.
1 second.
So always remember,
Yeah, done.
for a uniform conductor, for a uniform rod, rod is basically straight wire, है ना? Whenever there is a uniform rod, then suppose this is P and this is Q, and it says P is slightly positive and Q is slightly negative, then the EMF is equals to Vp minus Vq. And when you integrate this thing, when everything is constant, guys, when everything is constant over here, then what will be the only case? This will be equals to V into V, and you'll integrate only L, right? So V into V into L into sine dVL. I did the integration. So from that, when everything else is constant in uniform magnetic field. Are you getting my point, guys? For a uniform rod in uniform magnetic
Yeah.
field, E will be equals to this integration sign will be removed, and it will be V dVL sine theta. Clear? Is this clear? If suppose the magnetic field is
Yes,
acting
sir.
into the plane, then what will happen? Acha, I'll draw this as well. ठीक है, देख लो कितना लिखना. Also, this is note first one, note second. If B vector, B vector, and L vector are mutually perpendicular to each other, then in this case, motion notional EMF, motional EMF between the endpoints will be so when all three of them are perpendicular to each other, then what will happen? So can you see over here? This is the length vector PQ. Velocity. Can you see the length? Object is moving perpendicular to its length, right? Yes or no? Can you see the object is moving perpendicular to its length? Hello.
Yes, sir.
And if I say the magnetic field is like this or like a dot, so can you see in all these cases? In this cases, the EMF will be E. Okay, is clear? Sir, what will happen if the rod
Yes,
is
sir.
moving at certain angle? Then, if the rod is supposed like this, and the rod is moving like this, to say this angle. Okay, so if suppose this is the case, guys. If this is the case, then what? How will you solve it? Can anyone tell me how will we solve it? Or basically, what will be the EMF in this case? Can you see the angle between length and the velocity? Or basically, can you see length vector is like this PQ? Can you see the angle will be like this? This will be the angle. But anyways, my question is basically, suppose this is your the rod is like this, a little bit slanted, and B is now this. Hmm. The rod is like this, and the rod is moving like this. Can you see? No, nothing. It is going straight. Guys, the rod is going straight like this. It is executing translational motion, but it is not rotating anyhow. And it is slanted. In the previous case, it was like this and it was moving like this. In this case, it is like slanted and then it is moving like this. So can you see the difference in both the cases? Yes or no? Yes or no?
Yes, sir.
So in this case, what we can do, we can resolve this rod into two components. This rod can be resolved into two components. I think I have discussed this concept earlier as well. So can you see there is one component of the rod which is basically perpendicular to the velocity, and one which is parallel to the velocity, right? Can you see this is the component of length which is parallel to velocity, and this is the component of length which is perpendicular, right? Yes or no?
Yes, sir.
So always remember the EMF will only be because of will be induced only because of the component of the length perpendicular to the velocity. Okay, is this clear? Perpendicular to the velocity. So basically, L perpendicular only. This will not contribute to any EMF. Only this will be contributing to EMF. है ना? Why it will be why L perpendicular will only be the one which is continuing, which is providing the magnetic field? Tell me why it is only the perpendicular length. Why not? Hello. Why not this length? I told you, no. For motional EMF to be produced, the line should be cut. Suppose the lines are acting into the plane, and now your rod is like this. Can you see the rod is just brushing about the lines, right? It is not
Yes,
cutting the
sir.
lines. The lines will be cut by the previous case, right? So the magnetic field lines are acting like this, and when this rod is moving in this direction, then the lines will not cut. But can you see when this will be there? Can you see the lines are getting cut? So L perpendicular cuts the line, whereas L parallel is not able to cut the line. That's why EMF is only generated because of that component of length. It is perpendicular. Is this clear? Is this clear, guys? Is this clear?
Yes, sir.
No EMF. ठीक है देख लो please write down. Now you understood why it is called as motional EMF, because that EMF is because of the EMF is because of motion. That's why. Is this clear? Guys, whenever you're done noting, please done. So we did this case, we did the next case. Sometimes you might be given, if suppose theta angle will be given. Suppose if this is the case, and let's say this end is P and this end is Q, the slightly positive one and the slightly negative one, and let's say this is your length vector. Can you see length vector is always from slightly positive to slightly negative, right? Yes, enough. And now let's see if this is moving with a velocity v2. Can you see the angle between length and velocity is basically theta? Yes or no? And this is in a magnetic field. If angle between length vector and velocity vector is theta, then P will be equal to V to L sin. Here,
Yes.
please remember, if someone tells you, sir, if this is the case, then what will be the EMF to the rod or the wire? Suppose if this is the, and if I say thickness of this wire is negligible, if the thickness is negligible, will the wire be cutting any
Sir,
lines? Huh? Yeah, tell me.
sir, but because it's perpendicular to the velocity, isn't it going to be 90 degrees?
So sin 90 is how much?
Right. No.
Sin 90 is 1, right? It is not 0.
Yes, sir.
So hence it will be the maximum EMF in that case.
So
7.
is it necessary to write sin 90?
Not necessary, but लिखना है तो लिख दो. No one will pay any, no one will say anything if you don't write or if you write. But write down, it will
Okay.
indicate your conceptual clarity. If thickness of the wire is
Okay,
negligible,
sir.
then in this case EMF will be as the rod will not be cutting any lines. Okay. Shall we start doing some more questions on this? Now you understood now, but please remember this is only for a uniform rod in a uniform magnetic field, right? What will happen if the field is not uniform? Note the previous formula, this formula, all the formulas which we have discussed, they are only valid till the EMF or till the basic, can you see? Uniform magnetic field. Are you getting my point? So note all the above formulas are valid only for uniform magnetic field. For non-uniform magnetic field, how will we do it? We use, what do we use for non-uniform? Variable cases. Hello? We use,
Small element method.
so let's do a question based on that. Everyone is able to see an infinitely long wire, right? Carrying a current I. From this wire at a distance R, there is a rod of length L, negligible thickness PQ. This rod is moving in this direction with a velocity V. Okay. Now the question is, a conductor PQ of length L is moving with a uniform velocity V as shown parallel to a long straight wire carrying current I. Now the question is, find the EMF induced in conductor. Think it up and try to do this question and give me 5 minutes. I'll be just done. Easy question है. What do you usually do? It's not a variable. It's not a uh, uniform magnetic field. So basically, what will you do? We'll choose a hello. Guys, we'll choose a small element like this. Can you see one of the end will be positive and one of the end will be negative, right? Acha, I have one trick to tell you which end is positive and which end is negative. We'll use a trick directly for it, but for now use V cross V. Okay, I'll be just back. Hello. So yes, which end will be positive and which end will be negative? Can you see if what will be the direction of magnetic field, guys? The direction of magnetic field will be at every point. The direction of
into
magnetic field will be into the plane. Velocity is going upwards. So V cross B, right? When I do V cross B, what will happen? Which end will be positive and which end will be negative? So look, for that we'll discuss the. Oh, what just happened? So basically, what is the motional EMF? What did we do? We just want the magnitude. Will give you the law for which you will be easily able to tell you which end is the positive one and which end is the negative one without using anything. है ना? So here in this case, the motional EMF will be equals to what? If I say this is the small element and the EMF across this is basically DE. So DE will it be equals to B into V into what is the length of this thing dx, right? Yes or no? B into
yes,
V
sir.
into L, and can you see the magnetic field at a distance x will be equals to how much? This will be mu naught by 4 pi into twice of I divided by x. Yes, into V. Will this be the EMF? So what will be the total EMF? Total EMF will be integration of this d, and can you see mu naught 4 pi 2 I V will be taken out. So mu naught by 4 pi twice of I into V, here it will be 1 by x dx. Now can you tell me from where to where will be the limit? Can you tell me the limits of the small element?
R to R plus L.
R to R plus L. So hence this will be mu naught by 4 pi twice of I V into ln of R plus L upon. Everybody is clear why does it become R plus L upon R, right? This will be 1 upon x will be ln of x, and when you put it R plus L, it will be ln of R plus L minus ln of R. Well, whenever it is ln m minus ln n, that is ln n m upon n. Are you getting my point? So that is the answer. Okay. Please note we use right hand palm rule. To deduce the positive end. Wait a second. Either you can use right hand thumb rule or you can use shifts or snake rule as well to deduce the positive end of the word. Either right hand palm rule, learn something new, or we can use both. So let's see both of them. Okay, how will we use them? See, what does right hand palm rule says that you don't need to curl your fingers, anything. Don't need to do anything with that. Okay. Uh, Keep the hand straight. I'm not writing the definition part and something like that. I'm just telling you how exact directly up to apply this law. है So keep your hand straight, just like Congress ka panja, like this. Keep your hands like this, okay? Guys, hello. Everyone is able to do this, right? अरे मेरे को video
Yes, sir.
Yes, sir.
Can you see me? Hello. I'm not able to see. Can you see Congress the panja like this? Okay. So right hand, and make your hand straight like this. Now what to do? All the fingertips, all the fingers tips should be pointing in the direction of magnetic field. Thumb should be in the direction of velocity. So can you see your direction of thumb will be giving you what? Don't do it like this. So like this, guys. Okay. Can you see the creativity? Everyone is able to see the creativity, right? So basically, your thumb should be in the direction of your velocity. The finger's tip should be in the direction of the magnetic field. Okay. So wherever the palm, you will write it like this. The end facing the palm is the positive. Okay. So here in this case, in the previous case, can you see over here? Velocity is upwards. So can you see velocity be upward? Can you see my thumb pointing upward? Yes or no? And can you see the magnetic field over
Yes, sir.
acting into the plane? So hence my fingertips are pointing towards the screen. So can you see my palm is facing towards P? This is my P, right? This was Q. This was P. This was P. Sorry, this was P. This was Q. Are you getting my point, guys? So can you see P will be the positive end and Q will be the negative. The same thing can be applied to this small element as well. For this small element Mn, M will be positive and N will be. Are you getting my point, guys? Is this clear?
Yes,
Yes,
sir.
sir.
Okay. So this is your right hand thumb rule. Either you can use this, but why learn new when you have old things again? Whatever you want. Even I don't prefer SSS much in this. I prefer this only because this is easier. Right hand palm rule is easier in this. SSS rule may be a little. So again, it will be something like this. Thumb will be in the direction of velocity, and then all the fingers tip shall be in the direction of magnetic field. Then what will you do? You'll make a snake and bite wherever you will bite. That will be the positive. So again, can you see over here, guys? Velocity v in the upward direction. V is in the upward direction. Fingertips in the direction of the magnetic field. Can you see? Now make a snake-like structure. So made a snake-like structure. Can you see snake-like structure? So basically, this is my snake-like structure, and can you see towards P? Yes or no? So the snake is biting towards P, hence P is the positive. Is this clear? Guys, this clear? It's up to you, whichever you want to use. SSS is basically derived from right hand palm rule only. Okay? It's a fun way of learning, this right hand palm rule. So Schiff's snake rule is basically that. Are you getting my point?
Yes, sir.
Yes, sir.
Please write it. Is it fine if I have not written this statement like anything, right? I have written it like this. Is it fine? Are you able to understand this? And you need to apply it
Yes, sir,
twice or
it's
thrice,
fine.
then automatically it will go inside the thing. Will I give you one question, guys? Yes, guys, are you able to see a rectangular coil? Guys, are you able to see a rectangular coil?
Yes, sir.
Suppose this rectangular coil is like this, and we are pulling this rectangular coil out of the magnetic field with a velocity. Okay, this is A, this is B, this is C, this is the rectangular loop ABCD is placed in a magnetic field P, and this loop is getting pulled out with a speed V out of the magnetic field. This rectangular loop has length basically AB and CD is equals to L, and breadth or width BC and the DA is equals to 3. Okay. Thanks. So length and breadth is basically this. Now you need to find out if the loop is pulled out with constant velocity, then find the potential, find the first potential difference between points B and C, EB minus EC, and the second is the potential difference between point A and B. Also, what is given in the question, the resistance per unit length is L, or not L, it's lambda. Okay, think on this question, then later on start solving it. Okay, first of all, tell me in what branch, in which branch will there be an EMF induced? Will there be any EMF induced in BC? Will there be any EMF induced in BC?
Yeah.
No.
Yeah.
BC will have.
No, BC will not be having any EMF induced. Tell me why.
Why?
Because it is out of the magnetic field.
Oh,
There is
yeah.
no magnetic field line. If there
Yeah.
is no
Oh.
magnetic field line, what will you cut, right?
Yeah.
So since there is no magnetic field line, since there is no EMF induced in BC, is there
Okay.
any EMF induced in AB?
No,
Why?
AB.
because
AB. I'm
it's a
talking of
parallel.
AB. Can you see the
AB
length
no.
is parallel to the velocity?
Parallel to.
Similarly, CD also the length is parallel to velocity, right? C
Yes,
A
sir.
Yeah.
B A B this length A B and CD basically both are these cases are these application of this. Yes or no? Can you see? The length is parallel to the velocity. When the length is parallel to the velocity, what will happen? I'm sorry. Right? So can you see in this both the cases length was parallel to velocity, so hence the EMF was zero. So in this case, EMF will only be induced in where?
AD.
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 Can you tell me what will be the value of induced EMF in AD? B is basically the magnetic field. Where AD is present, the magnetic field is B, right? This is also moving
Yeah.
with the same velocity V because the whole loop is taken out, right? And what is the length of this thing?
B.
So what is the
B.
EMF induced?
B.
And what will be the angle? Sine 90 or sine 0? What should be this?
Sine 90.
Why sine 90? Because the angle between length vector and this is how much?
90
B. So basically this will be B into V into B. Is this clear? Is this clear, guys? Yes or no? Is this
Yes, sir.
clear? Now they have given the resistance per unit length is lambda. That implies the resistance of A, D, and B is equal. Since the length is equal, the resistance is equal, right? The resistance of wires, the resistances of RAD and RBC should be equal, and this should be equals to lambda multiplied B. Can you see the resistance per unit length is lambda multiplied by the length? Similarly, the resistance of AB and resistance of CD will be equals to lambda multiplied by L, right? These will be the resistance
Yes,
of the
sir.
whole thing. So basically what will happen, this question, which was a part of what? Which was a part of electromagnetic induction EMI, will not be EMI anymore. It will become current electricity. See how? This thing and control C, control V. See guys, this problem will become what? The problem will shift from EMI to current electricity. Now, can you tell me if this is the EMF, which will be bigger? Will A be bigger or will D be bigger? Can you apply right hand palm rule? Can you point your thumbs in the direction, thumb in the direction of V? If you point thumb in the direction of V, that is
B
more.
A is
will
bigger.
be
Then
is
A.
more.
A is more. A is more. Magnetic field is acting
Yeah.
into the plane. Can you see magnetic field is acting into the plane? So all your fingertips should be pointing towards your laptop. Your thumb should be pointing towards your right. Arrange your right hand in such a way that your thumb point towards right and all the fingertips point towards into the towards the screen of the. So can you see A is upwards and even the palm is facing upwards, right? So please remember here A is bigger. So VA minus VD should be bigger. Okay. Hello.
Yes, sir.
So basically what will you assume? You will assume that there is a battery with A having a, can you see the positive terminals towards A? Yes or no?
Yes, sir.
Yeah.
Now can you see there is a resistance in this branch as well, there is a resistance in this branch as well, there is a resistance in this branch as well, and there is a resistor in this branch as well. What is the resistance over here? Lambda into L. The resistance over here is lambda into L. Here the resistance is lambda B. Here the resistance is lambda B. Here the EMF is E, which we already know. So can you see the problem has been shifted from EMI to current electricity. Now what exactly are they asking? I think whatever they are asking, we can easily do it. They are asking what is the potential difference across B and C, and they are asking what is the potential difference across A and D. I think we are able to find it. Yes? Yes or no? So can you see what will be
Yes,
the
sir.
current over here? In this case, the current over here will be all of them are in series. Can you see all of them are
Series.
in? So it will be E divided by R total, and that will be equals to B divided by what is the total? Lambda
Lambda into 2L
into
plus B.
twice of L plus B. Yes or no? Can you see lambda L plus
Yeah.
lambda L twice of lambda L, lambda B plus lambda B twice of lambda L. So it will come like this. Yes.
Yeah, okay. Yes, sir.
So this will be the current. If this is the current, what have they asked? What if they asked what is VB and VC, right? So VB minus VC should be equal to I multiplied by lambda B. This should be equals to twice of V into lambda B. Lambda and lambda will get cancelled out. This will become B square, right? Guys, are you able to do this thing now? Anna? I think
Yes,
you
sir.
people are able to do this thing. You won't be needing my help now because once it gets converted to electricity, I think it is easier, right? This is the first part. Now, second part, VA minus VD. So for VA minus VD, what will you do? Apply open circuit Kirchhoff, guys. Don't do like this. Apply open circuit Kirchhoff. Can you see over here? I want to go from A to D. So when I enter from the positive terminal of the battery, plus or minus A, right?
Minus.
And then I'm moving in the direction of current or in the opposite direction of current.
Opposite.
Opposite
So
direction.
plus minus
Minus.
or
Minus.
plus. When we move in the opposite direction of current, then plus. When we move in the same direction, then minus.
Okay, yeah, yeah,
And
sorry.
don't forget current electricity.
I
That's
got
why we
confused.
spend
Yeah.
an awfully lot, time on current electricity so that your basic concept will be there. And I told you in the beginning only ki if your current electricity is good, a little bit of your EMI will also be good, right? And this is the reason why. So this is VT, sorry. So from here, VA minus VT will be equals to E minus I into lambda. I into lambda B is basically this only, right? Yes or no? I is basically this, right? Arey, hi. Minus I into lambda B is basically EBB square upon twice of L plus. So I think you are able to solve this as well. EBB will be common. 1 minus B upon twice of L plus. हो जाएगा solve, guys. I think you people will be able to solve it, है ना? मैं नहीं करता. Is it clear? Shall I give you one more question based on this? Hmm? Shall I give you one more question? I will do one thing. We'll do the other questions in the next class. That's it for today. Because those questions are a little bit good, and we'll need to apply fresh mind in that. Then the next class we'll be doing those questions. Okay. Okay.
Yes, sir.
Yes, sir.
Yes, sir.
Okay. Next class will be completely numerical based. So see what is the different types of variety of question which can be found in EMI. Okay. So thank you very much, guys. We'll see you again in the next class.